Okay. Question number 4. It says a car has a speed of 15 meters per second relative to the ground. So I'm going to write that. That's velocity of a car relative to the ground, and it is 15 meters per second. Then it says it passes a cyclist traveling in the same straight line. So they're moving along the same line. The speed of the car relative to the cyclist is 12 meters per second. So velocity of car relative to the cyclist. The cyclist, I'm going to represent it with the letter L. So velocity of car relative to the cyclist will be 12 meters per second. And the question is, what is the speed of the cyclist relative to the ground? So speed of the cyclist, which is L, relative to the ground, which is G. This is what I need to find. Now, we have a general equation for relative velocity that goes like this. Velocity of A relative to B equals velocity of A relative to a reference minus velocity of B relative to the same reference. So when you look at this equation, you need to identify which one cyclist, car, ground, or cyclist plays the role of the reference. So if you look at these three variables, you will identify that the common reference is ground because it's the second letter and it's repeated in two of the variables. So knowing that, I know that these two, velocity of the car relative to the ground and velocity of the cyclist relative to the ground, will go to the right side of the equation. So I'm going to write this same equation but using these variables. So it would be velocity of car relative to cyclist is equal to velocity of car relative to ground minus velocity of cyclist relative to ground. If you see, these equations have the same structure. You have AB, then A and R, and then B and R. In the same way, you have CL, and you have first C with ground, and then L with ground. So C goes first, L goes second, C and L. Now that I have written this equation, I'm just going to put the values. So the velocity of the car relative to the cyclist is 12. The velocity of the car relative to the ground is 15, and the velocity of the cyclist relative to the ground, that's what I need to find. I'm going to rearrange this equation. So to do it, I'm going to take this minus VLG, I'm going to move it positive to this side, because if I want to solve, I want this to be positive. So I'm going to get 12 plus VLG equals 15. And now I'm going to solve for VLG, and that will be 15, and this 12 goes to the other side, minus 12. So the velocity of the cyclist relative to the ground, which is the question that they're asking, is 15 minus 12, 3 meters per second. And when you compare, you see that the option is D.